What geological evidence helps identify ancient fjord geography? Have you ever wondered how scientists figure out the ancient geography of fjords? It's fascinating to think about how glaciers shaped these stunning landscapes. Let's break down the geological evidence that helps us understand ancient fjord geography. First up are U-shaped valleys. Fjords are formed when glaciers carve out deep, narrow valleys with steep sides. This creates a distinct U-shaped cross-section, unlike river valleys, which are typically V-shaped. The broad, deep troughs of fjords tell us a lot about past glacial activity. Next, we have overdeepening and thresholds. Fjords often contain basins that are overdeepened, meaning they are carved below current sea level. For example, Sognefjord in Norway reaches depths over 1,300 meters. At the mouths of these fjords, you can find shallower rocky thresholds or sills. These from where glaciers lost their erosive power as they spread out into wider areas. Another important factor is the bedrock composition and structure. Fjords are often found along coastlines with hard, erosion-resistant bedrock. This includes igneous and metamorphic rocks, which help maintain the steep walls of the fjords. The structural geology, including fractures and folds from ancient mountain-building events, also influences how glaciers flowed and eroded the landscape. Sediment layers and glacial deposits play a key role too. As glaciers moved, they deposited sediments in the fjord basins. You can find terminal moraines, which are accumulations of glacial debris, forming underwater at the entrances of fjords. These create shallower thresholds compared to the deeper parts of the fjord. Don't forget about preglacial valleys. Many fjords follow valleys that were originally carved by rivers before the ice ages. These ancient river valleys guided glacier movement and intensified erosion, leading to the deep and wide fjord basins we see today. Lastly, some fjords, like Hardangerfjord, consist of multiple basins separated by thresholds. This reflects the complex patterns of glacial excavation and sedimentation that occurred over time. In Scandinavia, particularly Norway, these geological features are well preserved due to repeated glaciations during the Quaternary period. The combination of ancient geological structures and intense glacial sculpting has created the classic fjord landscapes we admire today. Understanding these geological signatures helps us reconstruct the ancient geography of fjords and the history of glaciation in the region.